Hey everyone, welcome to another Common Lisp study group. I'm your host Ram Vedam with the Plant of Functional Programming. Today we're going to be discussing the actual meta object protocol as specified by CLOS. This is the real specification that is available to you. It originally started out, just to give a little history, in I think it was known as Portable Common Lisp, which was part of um, Xerox's distribution Common Lisp. I think it may have been InterLispD, so quote me on that. From there, the active user community kind of brought it up to kind of a standardization level. Although I don't believe it's part of the actual Common Lisp standard, it's probably implemented in most, if not all, major Common Lisp distributions. You could also find a portability layer that was written by Pascal Costanza in Closure Mop. That's what we're going to be leveraging today to kind of illustrate some of the features of the actual mop specification. Um, just to give folks some heads up, the link to the actual mop specification was provided both on Mattermost and on Discord. I also provided it for folks watching the live stream in the actual link description of the live stream. If you don't see it, let me know so that way I can update the description now rather than later. Um, let's begin. Um, the first, hold on, let me just first load up a closure mop here so that we actually have it. I'm going to be using a scratch buffer for our examples today, and then later on, hopefully, I'll set up some projects so that we can go through and have some projects that I could post online. So we kind of covered bits and pieces of this through our broadcasts the last few weeks while we were going through the Art of the Metaobject protocol, because while the book kind of goes through Closette, I wanted to make some of the, which is their implementation of a subset of CLOS, has a object-oriented programming program using the actual a meta-object protocol to build it up. I thought it would have been more appropriate, practically speaking, that a lot of folks would probably, who's using Common Lisp, use the mop specification as it was defined in Chapter 5 and Chapter 6. So I kind of gave you kind of like bits and pieces, and just so that it was a little bit more focused on the CLOS mop itself. That being said, for folks who are reading this book, the first 4 chapters in Part 1, especially, goes into not just Common Lisp mop itself. It's actually focused on the general principles of writing your own meta-object protocol in general. So regardless of what programming language you have, you could, if you wanted to, go through this exercise of designing your mop, and they gave some clear definitions on what at least the authors considered to be core elements of a foundation of generating a meta-object protocol for your language of choice. So I thought I'd go through some of these things in detail. Some of this might be review for folks who have been following us along, where I've been reviewing the mop specs themselves, or reading the AMOP book in various forms. As I go through this, if there are any particular questions, just go ahead and ask them away. This is going to be kind of informal, so that way we can go through and have some interesting examples and points of view to kind of like discuss and elaborate through. So to begin with, had a review. We know that the mop consisted of what the authors call basic meta-object classes. These are classes that the are kind of like the base level foundation of the Metaobject protocol, at least in CLOS. These consist of, class, slot definition, generic function, method, and now I didn't realize this until I started reading chapter 5. Also, method combination also has its own meta object. For folks who've forgotten or don't recall what method combination is, this is really the notion on how methods in the inheritance hierarchy get combined into a single method that can then be just invoked. So behind the scenes, your superclasses of a base instance, base class, concrete class that you're instantiating, they're methods that are all following the same nomenclature. How they get combined is kind of the basis of what the method combination meta object would define. Now, the meta object classes themselves that you specify when you're using this mop is a subclass of exactly one of these kind of base meta classes. The specification explicitly says that it is an undefined behavior if you try to do multiple inheritance and try to inherit from multiple of these meta object classes, primarily because the semantics of each of them kind of expect kind of a hierarchical structure, and there's this implicit hierarchical structure that's there when you use them as is. And if you do not, if you try to combine them in different ways, really is dependent upon your distribution. So the specification doesn't actually explicitly dictate what those what the multiple inheritance case of inheriting from multiple meta object classes are. Now, a meta object is an instance of any one of these classes, and usually we use them through user interface macros. Now, the folks who are listening in on this, when we say user interface macros, we're actually talking about the high-level API that actually allow you to define concrete classes in Common Lisp, although this can be generally defined, in my opinion, as part of just general API design on where you dictate your types are and then how you expect users to instantiate those types as you are building up specific types of applications. Now, with respect to these base classes, the user interface macros that most people are familiar with are def class, def generic, and def method. Now, in addition to this, there is a way of specifying. At least I think there was when I looked at this, specifying the method combinations ones. But other than that, the rest of them that you see, like for example, slot definitions, those are actually interacted through when you are defining your slots for a given concrete class through def class. So let's talk about the class meta object. I'm going to go pretty quickly here just because a lot of this should be kind of review. If there are specific questions that most people have, just let me know, and we'll kind of go through them as they come in. So the class meta object, as we kind of talked about before in Closette and now specifically for CLOS, consists of several things. One is of course your direct slots. Okay, these are slots that you're defining. Think of these as your instance variables of your class. This also consists of course the name of the class, the subclass, the inheritance hierarchy, so all the superclasses, the direct superclasses of this class. But in addition to the direct superclasses, you also have technically access to your direct subclasses through the Metaobject protocol. You also have, for this concrete class, the class precedence list. Now, again, as a review for folks here. The class precedence list is the order in which really method chaining, method combination, it's used to essentially figure out the specificity of your superclasses with respect to the concrete class. And there's an ordering that ends up being computed when the class Metaobject is being instantiated. When the concrete object, class definition is being instantiated. This is usually cached and then retrieved every time a new instance of that object is created. That's computed, if you recall, using essentially a topological sort on top of your superclasses to determine common base classes amongst classes that you're trying to inherit from, so that a more strict ordering is generated. This way you kind of resolve any ambiguities in terms of which methods is called when, in terms of the generic objects that you're inheriting from. On top of these slots, direct superclasses and other classes in this class precedence list, not to mention our direct slots, there's a few other interesting things that are actually available in the class Metaobject with respect to the CLOS mob. One is a documentation string. Now, a lot of other programming languages tend to have the documentation as a separate piece, as a comment almost, when you are reviewing particular classes themselves. But in Common Lisp, because if you recall, Common Lisp is a REPL, and you're usually doing interactive development when you're developing these things, you can actually query and inspect the descriptions of your classes. This brings up one thing that I tend to try to at least adopt, and I kind of want other folks to adopt, is as you're defining your classes and your meta classes, having a simple documentation string expressing the intent, because again, it allows things like describe and print object to give some more information about what it is you're instantiating. Allows us to use some of the features in Common Lisp without actually having to go out to external tools to go search up a documentation for a particular API, whether it be a class that you're trying to instantiate, or any of the other meta objects, any other objects that you're defining in general.
You can also define documentation for individual slots as well.
Interesting. Okay, I did not realize that. Okay, that's pretty cool. Okay, that's a very interesting point too. This I think also gives you some better ways of actually describing the objects that you're actually building up. I tend to. There is obviously a fine line between over documenting and under documenting. I just I err on the side of over documenting a little bit and try to clean it up as I go through. But depending upon your method calls and how you're defining your API, of course, it might be self-explanatory.
Also, you can for each slot you can define a keyword called type, which specifies the type that you intend to store in that slot, which, while it can't be queried, I don't think, it really aids in documenting the intent of your code.
Right, and
I don't think many optimizations will go into that as far as the compiler is concerned, but it's good for documentation.
Yeah, very, very good point. That also gives you an indication for folks who are looking at it at the class, kind of how the object could be structured in memory depending upon the Lisp distribution that you're using, because they might use certain optimizations when instantiating the classes themselves based on the type information that's available there. But I wouldn't necessarily guarantee that. But like Michael said, it is a good idea to have that available to you, because it really helps in leveraging the APIs that one is trying to access. Finally, for the class meta objects, I thought I would also mention the fact that there are the class meta object itself would include, the methods that the class kind of defines now, and the generic functions that are available to that class. This allows you to actually look up for a given class what it's kind of like its API. You can actually go and query some of those functions to see if a particular function has been defined for a class instance, and if it's not, that means you may want to go and define it for your given use case. Now remember, generic functions are not typed, right? So you could have a generic function in a different API, a different package that you could implement a specializer for your user-defined class in your own package. That actually is kind of like the common use case of leveraging generic functions. When you're doing that, of course, instead of like going through different packages, you could just go ahead and query the class meta object for that information. So the next topic is, of course, slot definitions. Now, if you recall, slots kind of go into two categories. There are two kinds of slot definition meta objects. One is the direct slots that we were talking about earlier, but in addition, there is also, and we talked about this a little bit in the past, which is the effective slot definitions. And the effective slot definitions is the meta objects that represent information, including like the inheritance computation about a slot, which is accessible for instances of that particular class. Associated with these, both of these meta objects, so to speak, is the following. You have the name, the allocation type, the allocation and type of the specific slots, as Michael alluded to earlier. Yes?
If you're typing, I don't see your screen shared.
Did I not screen share it? Okay, hold on 1 second. 1 minute. Go ahead and do that. I thought I did that already, but I keep forgetting that on there we go. All right. Sorry, 1 minute. Emacs tends to minimize itself every time I try to hide that Google Hangout scroll thing that's down at the bottom for screen sharing. So for these direct slots, the name allocation and type of the variable are for the specific slot that you're defining. Now, for allocation is not like mallocking. It's more of, is this a class variable or an instance variable? If you recall, when we were talking about CLOS in general, this allocation just kind of tells the meta object API what the sharing semantics are for that given slot. In addition to this, we have our init form or initialization form, which is could be a function, could be an expression, it could be just a value that you specify for a given slot instance of a class. Now, just remember, init form, for folks who are still getting used to the differences between init form and init-arg, init form is what is used when the class is instantiated initially, unless if you're calling in make instance, init-arg, because I think the order in which they get generated is the init form is first computed and then it's overridden by whatever's passed into to make an instance for init-arg. Init-arg is just the list of symbols of that slot definition that is, again, used by some of the higher level APIs to construct instances of objects. And I'm talking about initialize instance, make instance, and so forth. And as Michael talked about earlier, we have documentation strings that you can use to document this slot definition object. Now,
also reader, writer, and accessor.
Yeah, thanks. Reader, writer.
And all of these, except for name, are what are called slot options, and they are all optional. You don't need to include them. In the case of reader, writer, accessor, and init-arg, all of those are you can supply them more than once. So you can have more than one reader on a slot. You can have more than one init-arg on a slot if you want. But they are optional, 0 or more of them for each of them.
That brings up an interesting question. At least with respect to, I think we've talked about this in the past, but now this really kind of brings back that topic, and that is the reader and writers, multiple readers and writers for a given class. I guess.
Well, for example, one possible use case for that multiple readers would be, or multiple anything, like say that you wanted to expose to your users a reader on a slot, so they could read it but they couldn't write it.
Mm-hmm.
So you could supply a reader with a symbol that is exported from your package, but then you could also supply an accessor with a symbol that's not exported from your package, so that you yourself could still write the slot and read the slot with that accessor symbol, but your users couldn't.
Okay. Oh, okay. Yeah, that makes sense. So you'll have a public reader writer, and then behind the scenes you could have...
Yeah, it would just be a different symbol for both reader and accessor. That's one use case anyway.
Right. That makes sense, actually, because then you can have a different API that's more user-friendly than the API that you're actually creating behind the scenes.
Yeah.
So, I don't think there's anything else on this this object, but it is something to be aware of, that slot definitions do have all these options. It's not just, the stuff that we talked about, or even stuff that you've probably seen when you go and read common Lisp code. Some of them are more useful than others depending upon the use case. Again, but knowing what is available is kind of like helpful as you're developing your APIs.
Yeah, they're all optional except for name. So I mean, you don't have to supply anything, and then you could internally just access those slots with slot value.
Right. Exactly.
Even though they have readers or anything.
Right. And I think that's something to be aware of, because if you are trying to create a quote-unquote true, it's not encapsulated, but it is encapsulated with respect to the public API, if you will. You could make some of these slot values have none of that, and when you're leveraging your behaviors, that is, your implementations of the generic functions, using slot values one approach to accessing particular things that need to be updated. Now, that being said, there is that one exercise related to actually implementing true encapsulation that is available, that you could do, and you can extend the language to do that if you really needed it. Generic functions. Now, this is something that we kind of talked about, again, with respect to Closette, but some of them, the variables that I'm going to mention here is kind of the same that's available in the Closette implementation, but I think there's a couple of things that are not in here. Again, like with both slot definitions and classes, you have both the name, methods, and documentation associated with it. On top of that, you have kind of the default class. This is like if nothing else is defined, this is a default class of the generic function method object that's used to define the actual generic function. Now, I don't recall, I guess this is actually usually defaulted if you don't specify it in the function signature. to standard class in the specification. But of course, you could override that and make def generic onto a specific subset of a hierarchy. And that's what actually gets populated into this generic function meta object. Of course, you got your lambda list. This is your arguments. You have your method combination meta object that you're going to be calling. Well, it's an instance of the method combination meta object that is applied to this generic function. You may have seen this before when we defined, I think we went through method combinations with the prog-n method combination just to illustrate this. We can go through an example later on once I go through this quick overview. On top of that, you also have argument precedence order, which is useful for knowing what the order in which the permutations are used for lookup of the particular methods that implement it. And this is something that I wanted to bring up because the book says one thing, and I haven't found anything regarding this when I did the Google search, and that is related to a list of declarations. And I'm going to kind of quote what the spec says here, and then we can discuss it. We just type in argument precedence order and list of declarations here before I go through what the spec says. Now, the spec says this one thing, which is there's some ambiguity in Common Lisp about the terms used to identify various parts of declare special forms. In this document, the term declaration is used to refer to an object that could be an argument to a declare special form. And the example they gave is in the special form declare, and I will write this down for folks who are watching. Take this as an example. Of course, this can't be in the global space. If you define like some variable g1 and you say that you're declaring this special, the list special one is a declaration. Now, what is declare tells us that this is a declaration. So I'm wondering what the ambiguity is in this form. Has anyone looked into what the spec says regarding this? Because I've never actually.
What section of the spec?
This is in the hyperspec. It says that there's a terminological ambiguity on
the section up at the top.
Excuse me?
What's the section number of the spec at the top?
I think it was in the hyperspec, so give me a second. I have to go and look it up again. I have to get the spec number from the hyperspec.
Okay.
So, give me just 1 second. It's on. So, it's on the symbol declare section, which is in. What is the section here? Give me a second. Section 3.8 in the compilation vocabulary dictionary. Evaluation of compilation dictionary. Section 3.8 symbol declare. It talks about the declare specification, and they said that there's some ambiguity on the declare specification. I'm not quite understanding where it is, and it looked pretty clear to me in terms of if you specify with declare, that's a list of declarations. So
ambiguity. So I should search for ambiguity here. Oh, you're talking about the cleanup issue?
Yes.
Oh, okay. Let me see.
While Michael is looking up that, folks on the stream, if there are any questions, please let me know, and we can address them.
I see what they're saying here. Talking about the function declaration.
Oh, okay.
Yeah, I'm not sure how to describe. I think we can safely ignore that. I mean, that's
okay. Cool. I don't have to worry about it. Cool. All right. So, folks, unless you hit into this ambiguity issue, I'm just going to. I haven't hit it, which is why I'm a little confused by what exactly that is. But if you anybody watching this later on in the stream, or even who join us and try to catch up on the stream, if you guys have an example or something, feel free to put it in the YouTube comments, and I will address them at a later time. Finally, to just finish our overview, we have our standard method meta objects. Now, these meta objects are, i.e., those that are defined by def method. Def methods are your method objects that are those that are I think specified a little bit more. I think is a more appropriate one. Two instances defined by def method is probably more appropriate for this. Now, these method objects contain standard information related to the specific method, which is the qualifiers. Now, the qualifiers are those are the things that are the list of non-null atoms related to essentially finding the method when you're actually looking up the method in the list of generic functions. You have also your lambda list, which is pretty self-explanatory. You have your list of specializers. Now, these are your constraints on the lookups. These are the stuff that we talked about in the past related to like EQL specializers for primitive types. If you're constraining your thing on a specific object hierarchy, that's what's listed in the list of specializers and so forth.
So forth would be just the class type.
Yeah.
The class name.
Yeah, exactly.
That's all standard common list supports. Is EQL and class name specializers.
Class name specializers. Okay. There could be more. Well, that's what common list specifies, but I think isn't the well. I have a question about that, but I'll bring that up later in a different discussion. Then there's something here in the spec that is related to the essentially the function definition itself. This is the function that is applied to the arguments and can be passed into apply or fun call when you're actually when you've instantiated and you're invoking this particular method. The one thing that I was a bit confused about is this just because I thought that this is how CLOS works, but this description was a little confusing. Was when the spec says when the method is associated with the generic function meta object is available. A method I thought was always associated with the generic function. So like when you do a def method, for example, I thought if the generic function doesn't exist, it gets created. Is that's not
correct.
True? Okay.
So that's always correct.
Okay.
There's only one function object involved, and if it doesn't exist, it's created for you.
All right. So,
some implementations will warn. SPCL used to warn. It no longer warns, which I kind of don't like, because you should really describe your protocol first, which means define your def generic first. So you have the API available to whoever wants to see it.
Right.
Yeah. Generic functions are always existent for a method.
Okay. So this is.
I don't know what the spec is. Is that in the spec somewhere too?
That was in. If you go and read, and let me I'm going to go to meta modulars to Robert Strand's spec here for our folks to show them this one thing. Give me just 1 second. It's in the. Where are you? Hold on. Up to the table of contents. It is in. So here you go. So if you look at the CLOS mop spec, it's in the section on methods. It is the 5th bullet point. I will post this. Let me just share my screen here with a different. Let me pull this out because I know how crazy Inception works with Hangouts. This guy. So, like, if you look at the bullet point there, specifically item 5, it says it right here. When the method is associated with generic function meta object available. When will it ever be not ever not be associated with the generic function? I guess is my question. I don't think that's valid.
Yeah, that's beyond me.
Yeah, that's a question for another day. I'm gonna go look this up, folks. See if there's something that I've been missing, and I'll let you guys know if there's some updates to this. But as of right now, just assume that if the method that a method is always associated with at most one generic function at any time, and usually if the generic function doesn't exist, at least from my experience, I hope others as well, the generic function is created upon the def method being compiled. So at compilation time, when it's being defined, it will see if the generic function is available. If it's not, they'll create it and then assign it to the method Metaobject as part of its instantiation process. Finally, as with all of our other Metaobjects, I don't think I need to, mention this again, but I'll go ahead and do so. You are you can define documentation associated with a particular method. One thing to kind of really recognize is there is a lot of emphasis on API definition and documentation as you're looking at these meta objects in the specification. Again, this is kind of going back to encouraging this more interactive style of development where you are allowing the user to go and inspect your API as they're developing their code. On top of all these different, base Metaobject classes, there is a couple of things that I want to bring up that apparently are also Metaobjects. The specializers that we mentioned earlier in the method Metaobjects, they themselves are Metaobjects, and those are specifically 2 different types right now as defined by the spec: class names, specializers, and then EQL specializers. Both of those have just the information related to what it is the specializer. What? Oh, okay.
I got the answer. Apparently, you can create a method using just make instance on that meta object, I guess.
Oh, really?
And then that won't be associated with any generic function.
Interesting.
I never. That's a little advanced. I never really
heard of that before, but I guess it's a thing.
I mean, it makes sense given the fact that it is an object, but when would you ever do that is now a question.
Crazy mop nonsense.
Yeah, we'll put that in the category of crazy mop nonsense and then move on. Oh man.
Because then you gotta call add method in that case.
Okay.
Generic.
Interesting. That might be also related to some stuff that I've been trying to read up on allocate instance, because they said that adding allocate instance overrides to allocate instance are not specified. They're implementation defined. At least from what I read in the hyperspec when I looked it up, it's kind of odd, but it makes sense that there's this weirdness where you could create an instance of something and then add it in manually.
So the whole point of that is just saying that it's possible for methods to exist without generic functions because they have to be created first and then attached.
Right. Okay, that makes sense. Let's see. Now, the one last meta object that I'm going to mention as part of this overview that is really part of this, but the specification doesn't actually specify any structure, so this is implementation defined, is the method combination meta object. This is information, again, as I mentioned earlier, about how methods are going to be chained together and combined in terms of specificity of the inheritance hierarchy to create an effective method that can be invoked. The meta object specification does not, the protocol does not define any sort of predefined structure of these meta objects for method combinations, but they are technically part of the spec in terms of its recognition. So look at your mop, the mop implementation of the common Lisp that you're using for more information. It's kind of the best thing I can suggest if you want to know how your particular Lisp defines it. It may very well do some interesting things that are standardized informally, but the specification does not actually define anything related to that. Now, of these base meta objects, we now can introduce kind of the standard meta object classes that are available in the specification. That is, these are the built-ins that you can use today. We kind of looked at a couple of these already. Standard class is one of them. Standard method, standard generic function. These are all available to you already. You also have, for slots, standard direct slot definition and standard effective slot definition to look at the instances of those guys. And on top of standard method, reader writers and get their own kind of like special instances. So standard reader method, standard writer method are available to you too as well for you to override. But there's also a couple of other things that are built-ins, which is these are your standard meta object classes, but there are also additional things that are kind of base classed off of these that I would also consider predefined already. I don't know if they would be, they're not considered standard according to the spec, but they're available to you in terms of special purpose meta object classes. That's actually what they call them. And these are stuff for defining an object that is essentially a callable. That's a fun callable standard class. There's also a built-in class. This is for usually only for defining the primitive types and making them part of and registering those primitive types of your Lisp distribution as part of the class hierarchy. I don't even think that you can actually subclass this guy. But it's there mainly to get all the primitives into the class machinery so that you have a single kind of uniform API, whether or not you're dealing with, class objects or primitive types in the language. Then there's this one class that I didn't know existed, which is forward reference class, and I don't even know when this is necessarily used. I couldn't find information about what.
As far as built-in classes, it's an error to basically use built-in classes in any way except you can specialize on them in methods. Like you could specialize on the type list. That would use the built-in class list to dispatch with. But attempting to like make instance or subclass or anything like that is an error as defined in the spec.
So you can subclass built-in.
No, you can't. You can't subclass. You can't make an instance of a built-in class. You can't call like a reader because there really are no readers. That's implementation internals. You can't call slot value on a built-in class. You can't change class to a built-in class. You can't do anything with a built-in class except write a specializer for a def method.
Oh, okay. So that's the only case. Okay, and that makes sense. That actually is, I think, preferred behavior, since that would force certain semantics to be available and assumed. I just didn't understand you when you were saying about the specializer. So the only thing that you can do is define a method that overrides or extends a built-in class by specializing on that built-in class.
Well, not really. Yeah, not really overriding. I mean, your own method could do something different depending on whether it was some kind of built-in class or maybe even something else was equal dispatch. Or like you could say, you could have a method that's your own method to iterate over a sequence or something. You could specialize on the sequence built-in class. And that would work for both lists and vectors.
Got it. Okay. All right. That makes sense. But this forward referenced class is a question of mine. So if I wanted to forward reference a class so I can use it in another class in terms of its hierarchy, do I have to actually then subclass forward reference class in order for me to make it a forward reference? Have you ever seen this before?
I have not.
Okay, cool. All right. I'm just going to assume that that's one of those classes that was defined for a specific purpose but no longer is needed. Just because the book doesn't really tell me when to use such a class, so... Oh! Got it. Here it is. Never mind. I stand corrected. When the definition of a class references another class which has not yet been defined, the implementation automatically creates an instance of forward reference class for you until the class is actually defined. So
I kind of figured as much.
Okay.
Like that's really to figure out the precedence order.
Right.
So you don't have any similarities.
Right. And it basically tells me that you're not supposed to actually subclass forward reference class. The only class that you'd want to subclass anywhere is if you wanted to create a specialized thing of fun callable standard class, and that's it. Everything else is kind of don't even bother into. I'm just going to even write this down for folks watching this. Don't built-in class and forward reference class are defined for specifically for implementation semantics and are not supposed to be extended. This is something that's pretty important, just so that you're kind of aware. So if you guys are reading through this, I'm just going to...
Builtin Classes is part of the standard. A forward reference class is part of the map.
Okay.
So the latter doesn't exist in the spec, as far as I know.
Okay. And forward reference class is part of the map spec. Not even part of the standard. It's part of the map specification. Built-in class is part of the standard. Now, I'm just going to take a small break here and share for folks watching this nice little diagram that's on page 141, but it's available in its entirety from Robert Strand's site here on Metamodular, and that is the inheritance structure of the Metaobject classes. Now, for folks who are looking at this, this is kind of telling you kind of the superclass hierarchy of all these classes. Notice that, for example, the base class of reader method and writer method explicitly is standard accessor method, which is a subclass of standard method. So if you're defining like :accessor, you're probably instantiating standard accessor method. But if you're specifying one of the other two, readers and writers explicitly, they're just more restricted versions of standard accessors. Additionally, another thing to point out here is notice for the specializer meta objects, EQL specializer is explicitly defined, but class name specializers is not. That's kind of true because of the way kind of method lookups are being implemented. That's something that I want to call out explicitly. Other than that, some of these are kind of straightforward. We kind of revisit these things in various forms, throughout our exploration of CLOS. But it is something to be aware of. A question I had, and I don't know, Michael, if you've experienced this, but I'm guessing that this is the same thing for fun callable standard object, and that is, if you wanted a subclass fun callable, you'd want a subclass fun callable standard class, not fun callable standard object. Just like for folks who are subclassing and trying to create their own standard classes, you subclass standard class, not standard object. Is that true?
Let's see. Yeah, I don't know.
Okay, I'm gonna try it out and see if that's an issue.
Give it subclass fun callable standard class.
Okay, that's what I thought. All right.
Yeah, it was my impression from the book that you only inherited from standard object or fun callable object if you were implementing your own like high level, like basically if you were implementing your own like CLOS or whatever. That was my understanding, my takeaway from that.
Okay. Thanks, Michael Gargano.
Can we talk a second about the fun callable objects? Does anybody have like a good exact definition about exactly what that means and how that works?
An exact definition of fun callable objects in general?
Yeah, like I get like kind of what happens, but what is like the mechanisms at play in there that make those things different than the other objects?
Fun callable objects. I was under the impression when I read this is kind of like the at least in terms of the categorization, that their behavior is the same as to put it as an analogy, kind of like callables in other languages, mainly that there are certain functions they must implement in order for them to become fun callable. So it's not just enough that you subclass from fun callable standard class, but you have to kind of like implement certain methods in the generic function hierarchy in order for them to be fun callable by definition. And that's like, I'm assuming that there's like a call generic function somewhere that they have to implement in order for them to be fun callable. So that way, when you actually use either fun call or apply behind the scenes, that method is what's invoked in order for the instance to actually run its function. But I could be wrong on that. But that was kind of my impression when I was reading through that, just in the book. I haven't actually gone through a detailed investigation of it though.
Yeah, I wasn't sure because obviously I would assume that the standard functions in Common Lisp were also fun callable, right? Like CLOS or
let's see.
something like that. And I'm assuming those are not defined inside the CLOS object hierarchy in any way. So I didn't know if there was some more base just Common Lisp mechanism at play there when you said something was fun callable, or if it was just strictly related to something in class.
Well, let's see here. I think it's class of, right?
Well, it just makes the class a function. Like if you were to define like a class called map with the meta class fun callable standard class, map becomes a function.
Right. But you would have to still so you wouldn't necessarily have to implement any. I mean, it recognizes it has a function, but you'd have to, I guess, implement something in order for it to invoke itself, right? Like you would have to be able to.
I'm not really that familiar with it all.
Yeah.
That's basically just my high level understanding about it.
Yeah, and I figured that was kind of the case there. So let's see here.
There's a map function called set fun callable instance function that might be useful.
Set fun callable instance function. Let's see here. I'm wondering if we're skipping ahead, so let me just look at something here.
I have no idea. Like, this is pretty new to me. I mean, I've always known it in the back of my head. I just haven't ever had a use for it, so I don't have experience working with fun callable objects.
Certainly, and I think, excuse me. I'm certain that there are special cases for there where it's more appropriate to do like a fun callable standard class implementation versus just a normal function. One thing I could think of is at least implementing actors, for example, inside Common Lisp if you wanted to do that without doing a full-fledged closure-oriented programming approach to defining actors for concurrency. You could theoretically create a fun callable standard class to implement those semantics. Of course, there might be other situations too where it might be appropriate to doing some of that, but I'm not entirely certain. Now, the spec talks about essentially, and we've kind of gone through some of these things in terms of implementation, user specialization, um, with regards to how one would leverage some of these and extend the common Lisp object system with their own like extensions by defining specialized subclasses of these meta-object classes. Um, and we'll just quickly go through, some of these categories because we've actually gone through a lot of these in the earlier chapters of part one, and that is the categorization according to the book on the differences between what they say are specified by the specification, and those are the meta objects that are defined in the document itself. Stuff that you defined, which are implementation specific. And they have a third category that I'm a little surprised that was actually there, just because I kind of assumed that it's the decision of the implementer to define whether or not it can be portable or not. But they made the portable meta objects a special categorization. And then we've talked about specialized on how some of these implementations of the methods are created in earlier episodes. So I encourage you guys to look at those. But very briefly, this is kind of the same stuff that we talked about specifically for implementing methods when you're designing an object-oriented program. And a lot of those principles apply here too as well. So a couple of things that I wanted to discuss, at least with the folks on here, is implementation restrictions, which is primarily with respect to writing portable programs, just mainly because of the fact that I'm a fan of writing portable programs as much as you can. There's a couple of methods in here that I never actually leveraged, but I'm guessing that these are the things that you were alluding to earlier, Michael, which is add dependent, remove dependent, and map dependents to specify methods on a generic function that's been available. In addition to that, I think there was a couple of things related to allocate instance that are in here that didn't actually get brought up in earlier episodes, that, or even in my earlier investigation of the hyperspec, that I'm going to just bring up now. From my reading of the hyperspec on allocate instance, even though it exists, there is no distinct explanation on how you deal with adding a specializer for allocate instance. There's a function in the hyperspec called allocate instance : add. I'm assuming that that's what's used to actually add methods on top of that generic function. Never tried it. I encourage folks who are watching, and those of you that are on the call, that if you try this and you're able to actually be able to create your own allocator for things, let me know, because I'm kind of interested in this specifically for a use case that I have. I'm not sure if it can even work or not. So this is kind of like unknown territory for me, at least even with respect to the specification, but I'm going to bring it up anyway. So let's talk about the UI macros. We've already kind of talked to a couple of these, and let me switch back to actually, I think I could go through this one. Just 1 second. Is this available? I'm assuming this is available in the map spec. Yes. Okay. So we've already talked about def class, def method, def generic, and but we've never actually talked about defined method combination. Defined method combination, I think this is a very rare thing to do. Most people end up using standard method combination anyway, but I'm going to bring it up just for folks to kind of look at what this is. you can actually define the order in which you want to actually chain different methods when you're looking up the specificity of the method based on the class precedence list and so forth. Couple of the predefined method combinations that are already out there. We've already talked about the standard one, which is the one that allows you to use before, after, and around methods. But there's also stuff like prog_n, which will automatically take a series of methods and run them sequentially. There is
I use that one a lot.
yeah, I think I've used that quite a few times myself. There's also the addition specializer for folks who are writing UIs, especially with a CLIM. I've used this in CLIM on more than one occasion. The addition specializer is really, really useful because it actually allows you to implement decorators very, very, very cleanly. It isolates different aspects of adding stuff to a UI compositionally, and the addition specializer will then combine them all the way it should be done. There are other special method combinations that are available to you, but if you need something specific and it's not available, defined method combination is at your disposal to actually define those semantics. And it will create, again, a method combination Metaobject whose structure is defined by the implementation that you're using. Other UI macros that are available is stuff that honestly I don't think I've used, but I'm guessing that they're just implementations that aren't available. That's generic flat and generic labels. I've never used them. I don't even know when you would use them. I'm guessing it's at some point.
Wait, what?
There is something here that says one of the symbols: class, def method, def generic, defined method combination, generic function, generic flat, or generic labels. I'm assuming that generic labels and generic flat are functions that are available in closure map. I haven't looked at them. I'm assuming they exist, but if they're not there, I'm happy because that tells me that there wasn't a use case and they just defined it in the specification for whatever reason. The reason why these are called UI macros, I think it's important to at least introduce folks to this approach in Common Lisp versus other languages is, again, this is defining your API. This is your protocol to interact with the Common Lisp Object System Metaobject protocol. This is what is used to instantiate those different meta-objects that we discussed earlier. And more often than not, this is probably what you're going to be using instead of extending the language for your own things. I don't think that you can certainly follow this and create your own things for your language extensions, like define whatever that will generate a def class behind the scenes. But again, this API is very simple enough that you can get pretty far with just using this as is. Let me see, what else did I want to bring up here? I'm going to, with 10 minutes left, I think we're going to just, kind of stop here because there's other things on sub-protocols that I don't want to rush through that I think is important for us to discuss a little bit. I want to come up with some more concrete examples on that. But are there questions from our audience on YouTube?
I just think it's pretty crazy that all this is available. It's no feat to go designing something like this and make it presentable and usable, like in every way possible by users of the language.
I know.
It's not just hidden in the background and used by implementers or anything like any other object system like Python or whatever. It's like it's pretty powerful. You can do anything with it. It's just crazy to think about how they went about designing this. It's such a perfect way.
Yeah, it's really, really like a testament to the engineering of this, because I honestly would not have thought about this deeply, um, and come up with a system that is practical, that can be used very, very, very effectively with just learning the basic principles of object-oriented design, is kind of really very, very, very. I mean, I can't say more about it. It's just so awesome. Um, and I'm glad that implementers actually implemented this in various shapes and forms in their distribution. Um, Looks like there's no questions. Before I let you guys go, again, I want to bring out a couple of reminders for folks. In a couple of weeks, we're going to begin. We're probably going to take a little break from uh, uh, doing MOP stuff to introduce you to a game programming series. Michael Fiano, I think we're still on schedule, I'm assuming, for March 27th, April 3rd, and I think it's right after the game jam, the week after that. It's either April 3rd or April 4th. Let me go and double check this again. It was March 28th, April 4th, and April 11th for talking about game programming libraries. In addition to that, again, if you guys have any talk ideas, let me know. Still working through the website. Hopefully, I can have that in soon. And the game jam. The game jam is the first week of April, right, Michael? It was 4th through the 11th.
April 10th.
Okay, 4th through the 10th. Got
April 10th. It's a 2-week jam.
Okay.
It hasn't been officially announced yet. I usually do that about a month ahead of time. So
Okay. Sweet.
2 weeks that I'll have the website up. But
Okay.
it's going to be April 10th to April 10th is a Friday. So I usually give everybody, or I always give everybody 2 full weekends, like extended weekends. Like usually people start when they get home from work on Friday evening, and that goes that weekend through the next weekend, and then Sunday night will be the last night. So 2
Okay.
weeks.
2 weeks. Sweet. All right. Stay tuned for more information about that. Hopefully, the game programming series that we're going to be hosting will be useful for some of the stuff that going to be brought up during the game jam. And if you guys have any,
I'm sorry, 10 days, not 2 weeks.
right, 10 days, right.
So it'd be like, and then it ends at midnight that Monday morning.
Got it. And stay tuned for more topics. We're going to be continuing our discussion on Chapter 5 of AMOP and the MOP specification, and we'll hopefully get introduced into the last chapter, which is on generic functions and methods themselves. So until next week, if there aren't any more questions, I will see you guys, and have a great weekend.
Thanks, man.
No problem.
Have a good one.